using IC-55 timer, and this is a IC-55 timer. It has 8 pins. How the pins are being connected, it is very clearly it is being told in the classes. Therefore, already the values are also being given here. Values are also being given here, and the expected waveform. This should be the output waveform, and this is the waveforms across the capacitor. And then we are coming for a corrections. Now this is IC-55 timer. You should take care of that, the front side and the top and the bottom. Therefore, and this is a notch. You can put it in the top, and this is I just place it. Pin number 1, 2, 3, 4, 5, 6, 7, 8. Now you can see here that pin number 8, and pin number 4. Pin number 8 and pin number 4 are both connected to the VCC. Pin number 4 and the pin number 8 are both connected to the VCC. Therefore, VCC means here this is a power supply, and the VCC means here it is a 5 volt only. Therefore, what is the 5 volt? You connect it in the 5 volt. You connect to the 5 volt. Both of them are connected to the 5 volt. Then you can see from the diagram, you can see, it's a pin number 4 and 8. This is the 8. This is the 8. This is the 8. This is not the 8. This is the 8. Therefore, pin number 4 and 8 should be connected to VCC. Next, you can see here that in between 8 and 7, RA is being connected. RA is equal to 3. RA equal to 3 kilo ohm. This is a 3 kilo ohm. This has been connected between 8 and, this has been connected between 8 and 7. This has been connected between 8 and 7. You can look at that. This has been connected across 8 and 7. This is connected across 8 and 7. Then you can see another resistance RB is been connected between 7 and 6. 7 and 6. This is a 6 kilo ohm. That is approximately, you can take 6. Whatever available with the lab, you can take that and you can connect it, and you can connect it here. You can connect it here. Next, you can see one capacitor is there. There are take very careful that 2 capacitors are there. One is 0.1 microfarad, another is a 0.01 microfarad. Therefore, you can see that one bigger size, which is a slightly bigger size, equal to is the 0.1 microfarad. A slightly smaller size is the 0.01 microfarad. And you can get it measured also. Therefore, this is also to be 0.1 microfarad has to be connected to the between 6 and the ground. Between, you can 6. One end is the 6, another end is the ground. Therefore, we are connecting to the ground, and one end is the 6, another is the ground, and therefore we'll put a grounding here. This is a with an wire, just you place a grounding here. And very important thing is that don't forget it. Therefore, you can see it here that 6 and 2 are being connected together, shorted. 6 and 2 are connected together. That is the very important thing. Therefore, 6 and 2 are being connected together. And you can see that pin number 1 is grounded. Pin number 1 is grounded. Therefore, pin number 1, you can place it to the grounding. Grounding, you can place it the power supply. Black one, you can connect. This is grounding. This is also grounding. Okay, we connect together. After all this is a grounding. These 2 are grounding. So just identify that. Another one is a 0.01. 0.01 microfarad will be connected to the That is just a mistake it happened here. It should not be 6, should not be, this is a grounding, therefore we should not use that pin. We should not use that pin because this pin is indicating pin number 5. Therefore you should not use. You can use which is any other pin, you can, any other place you can use that. You can use any other place. And that pin number 5, again it should be connected one another pin number. This is this. Therefore you can see pin number 6 and this is a pin number 5. You cannot connect these two because pin number 5, this is a pin number 5. Therefore pin number 5, another capacitor is to be connected, and these two, then capacitor other plate should be grounded. Capacitor other plate should be grounded. That should go to the ground. That should go to the ground. And pin number 5 also, other end should go to the ground. Therefore you have 3 grounding. One is from pin number 5 other end. Capacitor other end will go to the pin number 6. Capacitor other end will go to the ground. And pin number 1, this directly grounded, pin number 1 is directly grounded. Therefore these three you have to directly, it will go to the grounding, and grounding can be done by the black. You can see the black terminal of this, you can do the grounding. Then you come to the channel. Already we have adjusted these channels. Channel number 1, you can go for an output. Channel number 1, you can go for an output. Output will be taken from the pin number 3. Pin number 3, you can take the output. Pin number 3, you can take the output. And pin number 6 is your capacitor waveforms. Pin number 6 is the capacitor waveforms. Therefore, you can output can be taken from the channel number 1. Show it. Channel number 1. Channel number 1 can be is the output. And the black one can be connected to the grounding. And then another channel number 2, you can go for a capacitor. Capacitor waveforms. You can go for a capacitor waveform that is also to be connected to the grounding. Therefore this is the, don't connect here because it can be touch the other things. After that you just switch on it and switch on that, and then you just press any key so that it will both the channels. Then you have to adjust it. You can see it is immediately it is coming. Therefore channel number 2 is indicating your capacitor waveforms, and channel number 1 is output waveform. Exactly what is the expected waveform that is coming. It is high, and you can adjust here with the channel number 2. You can see here another thing is very important. By positioning, you can see here while output is high, the capacitor is charging. While the output is low, the capacitor is discharging. That is the complete output you are getting, and that is the experiment number 6.